Hello friends, welcome to this video. In this video, we'll actually cover a very important topic, which is let me find out this topic. Excuse me. Yeah, this is the question. For incident angle I, refracted angle R. Okay, so incident angle is I, refracted angle is R. When light enters into optically denser medium from air and exits it, for the thickness of the medium as T and lateral displacement del. So find an expression for del in terms of these things. So I think you're familiar with the basic concept of refraction. If you're not, let me just tell you. So let's say I have a medium here. That could be anything. Say a glass slab. That's the most common example. So let's say this is a glass slab. Let this medium be N2. N2 corresponds to this medium, and this medium here is air, and this is also air. So obviously the glass is a bit, it has a more density than air. It's a bit more dense particle than air. So if light strikes one surface, then you see as it is more dense, then the phenomenon of refraction will take place. This is not reflection, this is refraction. Okay, so light will bend towards the normal. So let's draw the normal at this point. So light will bend a bit towards the normal in this case, and then at this point also if you draw another normal, then light as it is at this point, you see it is moving from a denser to rarer medium, so the speed of the light will increase a bit. So in this case light will bend away from the normal, and yeah, these two lines will be parallel. Let me show you how. There is nothing to show, actually these two angles will be equal, so this line and this line should be parallel. So that means if you extend this line, okay, you're getting it right. So in that case these two lines will be parallel, okay, and this is called your del. This is the amount by which light has been shifted. Now we are not considering prism. If you consider prism, a triangular prism for instance, in that case the light will like behave something like that. So in that case there is also some angular deviation, but here it is just lateral displacement. Light is coming here, light is being bended, like light is just moving a bit like this, and then light is again. So these two rays remain parallel. So if the glass slab would have been absent, light would have followed this straight line path, but due to this light is following this path. So anyway both are parallel, but light has been shifted a bit, and that is called the lateral displacement del. And what is your incident angle? Obviously this angle here I, that means this angle, by the way, let me just produce this here. So 90 degree. I need to do one more construction. Draw one line here perpendicular to this line, okay, 90 degree. So anyway these two lines are parallel, so if this is del, then this line which I just drew, that is also del, right? Okay, so if this angle is, let this angle be I, and what is a refracted angle? Refracted angle is the angle by which the light has like the bended, okay. So you see this angle here will be R, and this angle will be C. Let this angle be X. So R plus X is I, because see I and they are the vertical opposite angles, right? R plus X is I, that means X should be not capital I, small I, okay. So X should be I minus R. So this angle here should be I minus R. I hope that is clear. Now we will just apply trigonometry, and yeah, what is the thickness? This is the thickness of the second medium. This is T, that means this here is T. So considering this triangle, which I am just shading out now, notice very carefully in this triangle, okay. So this is the right angle, this is the R. So let's find out sine of R. Sine of R means this side, okay. We don't know what this side is, so forget this approach. Let's consider cos of R now. Cos of R is this side. We actually know what this is. This is just T over this length, okay. Let this be A, this point, and let this point be B. So T over AB, right? Now you consider this triangle, this right angle triangle which I am shading out. This here, and this here. In this angle, this is I minus R. So what will be, let's say sine I minus R. What will be sine I minus R? See, sine is the opposite side, that is del. We could have used cos I minus R, but you see, for cos we have to use this side. So we don't know what this side is. We don't have an expression, anything for that. So we consider sine. So this will be opposite side, which is del, over the hypotenuse, which is again this same thing AB. Now from this we can write that AB is del over sine I minus R. We can just cross multiply, we can write that. Now putting this value of AB in this expression, we get cos R equals T over AB, that is T sine I minus R over del. So del will be, excuse me. So what was our aim in this video? To find out an expression for lateral displacement in terms of thickness. In terms of the thickness of the medium. So yeah, just cross multiply, we see that del will be T sine of I minus R divided by cos R, where del is the lateral displacement, T is the thickness of the second of the denser medium when light is moving from a rarer to a denser medium and exiting the denser medium also to the same rarer medium, like in this situation. Okay, so that is our formula, T sine I minus R cos R, where I is the incident angle, R is the refracted angle. And by the way, this is called an emergent angle, but we tend to use this in this formulas in this video. So that is our expression. Okay. And that's how we derive this, and this is a very important concept also. So that was all for today's video. I hope you enjoyed it. Thank you very much.